For this next example, I am going to use the first triangle from that first page of notes. I haven't done one of those yet, so I'm going to do it here. We are given that we need to integrate x cubed dx over the square root of x squared plus 4. So I'm going to go ahead, just like I've done before, and start out by drawing my triangle. In this case, the radical is going to be my hypotenuse. And then x and 2 are going to be the two legs. So I've got this and this. Tangent theta is equal to x over 2. And so I can rewrite this as x equals 2 tangent theta. And then when I take the derivative, I get dx is equal to 2 secant squared theta d theta. And in this example, I want to make use of both of these bits of information. And then I'm almost done. Secant of theta is equal to the square root of x squared plus 4 over 2, opposite over adjacent. And I can rewrite this as the square root of x squared plus 4 equals 2 secant theta. So I have lots of things to go ahead and substitute. So back up here now. We're going to integrate. X cubed is going to be 2 tangent theta cubed. Dx is 2 secant squared theta d theta. All over the square root of x squared plus 4, which is 2 secant theta. So what do I have? Well, I now have 8 tangent cubed theta. The 2's are going to cancel. I probably wrote this too high. Secant goes into secant squared, so I've got 8 tangent cubed theta secant theta d theta. And again, probably doesn't need to be written so high because I don't have a fraction anymore, but it's all good. What I'm going to do here is I'm going to break up the tangent cubed theta. So this is going to harken back to the last section. I'm going to break that up as tangent squared times tangent. And I'll go ahead and move that 8 in front. So I've got tangent squared theta times tangent theta secant theta d theta. Tangent squared theta using a trig identity is secant squared theta minus 1. And when we integrate, instead of tangent theta, secant theta, we usually see it in the other order, secant theta, tangent theta. So I'm going to rewrite it like that, just how we're more used to seeing it. So now I've got secant squared theta minus 1 times secant theta, tangent theta, d theta. I'm going to break this up into 2 separate integrals. I'm going to do u substitution with the first, and the second one I can just straight up integrate. So I have secant squared theta, secant theta, tangent theta, d theta, minus 8, and then we're going to integrate just the secant theta, tangent theta, d theta. So like I said before, the first one's going to be a u substitution. The secant squared theta would be our u squared. The secant theta, tangent theta, d theta would be our du. So if we were to integrate this, we would have 1/3 u cubed, which would be the same thing as 1/3 secant cubed. So again, that's going to be 8 times 1/3 secant cubed theta. Then over here, we just get minus 8 secant theta plus c. We are almost done. Secant theta is equal to the square root of x squared plus 4 over 2. So I need to go ahead and replace that in both of these first two terms. So I have 8/3 times the square root of x squared plus 4 over 2 cubed minus 8 times the square root of x squared plus 4 over 2 plus our c. Can't forget that. Almost done. When you cube the x squared plus the square root of x squared plus 4 over 2, when you cube that, you're going to get an 8 in the denominator. The 8 in the denominator is going to cancel with the 8 up here in the numerator. So we're just left with a 1/3. And the square root of x squared plus 4 cubed, I'm going to write that as x squared plus 4 to the 3/2 power. Here, the 2 cancels into the 8, so I'm left with a minus 4 times the square root of x squared plus 4 plus c. And we're all done with that one.